All right, this video focuses on the normal distribution and the percentages. So this is the graph for the normal distribution curve. The center is going to be your mean. And then it's equally distributed on the right and the left side. This notation here, if you remember, is your standard deviation. So if you go one standard deviation to the right or one standard deviation to the left, so plus or minus one standard deviation, 68% of the population will fall there. So if we equally split it, here is 34.13% and 34.13%. This right here is 68% total. If I move two standard deviations left or right, so this is plus 1, this is minus 1, 95% of the population will fall between the two purple lines. So this region between plus 1 and plus 2 is 13.5%. This region is another 13.5%. If I go plus or minus 3 standard deviations, so here's plus 3, here is minus 3. So between the blue lines, 99.7% of the population will fall between plus or minus 3. So this region here is 2.15%. This region here is 2.15%. There's one last region. Above 3 standard deviation is 0.13%, and below would be another 0.13%. Here's just a new graph of that same in a shortened version. Okay, so example 1, it says the sample of cans of peaches was taken from a warehouse and the contents of each can was weighed. The sample, so the average of every can totaled up and divided by how many cans you have, the average weight of the cans is 486 grams with a standard deviation of 6 grams. So I'm just going to go ahead and write that down. So my mean, my average, it was 486 grams for the peaches, and then the standard deviation was 6 grams. So I'm going to graph this out. I'm going to start with the mean. So that mean is 486 grams. When I move one standard deviation up, so plus 1, I'm going to add 6 to it from the mean. So 486 plus 6 is 492. If I want to go plus 2, I would take another 6 and add on to that, giving me 498. So what I've done to save us a little bit of time is I've identified the mean. This is plus 1, plus 2, plus 3, and then go minus 1, minus 2, minus 3. Now, the question is this. State the proportion of cans, so proportion is your percentages, between 480 and 486. So we look, here's 480, here's 486. What is that percent? Well, that falls minus 1 to the mean standard deviation. So it's 34.13%. This is the region that we're just looking at. So the answer then is about 34.13% of the cans are expected to fall between 480 and 486 grams. Example part B. The sample of the cans was taken again. So I'm looking now for more than 492 grams. So remember, this is where your mean is, 486. We want to find out where is 492. That's up above. Here's 492. And we want to add the percentages above that. So here is that graph again. And we're going to add up these percentages in our calculator. So when we add them up, we get 15.87. So this percent is 15.87%. So it's expected that about 16% of the cans will weigh more than 492 grams.